The greatest scientific debate of the 20th century. Quantum Quandaries. An evening at Einstein's office. Setting: the Advanced Institute in Princeton, late 1940s. The evening air is crisp and cool, with a slight chill indicative of the approaching winter. Inside the institute, the atmosphere is one of quiet intensity, as great minds grapple with the fundamental questions of the universe. Einstein's office, a chaotic blend of books, papers, and chalkboards filled with equations, serves as the battleground for a passionate debate between two titans of physics, Albert Einstein and Niels Bohr. Characters: Albert Einstein, an older, thoughtful man with unruly hair and a piercing gaze. His office reflects his mind, filled with both brilliance and disorder. Niels Bohr, a vigorous and animated thinker whose calm exterior belies the intensity of his convictions. Hannah, Einstein's assistant, a young and diligent woman who maintains a quiet presence, ensuring the office functions despite its disarray. Prologue. The sun had set over Princeton, casting long shadows across the campus of the Advanced Institute. The halls were quiet, save for the occasional murmur of conversation or the soft rustling of papers. In a corner office, light spilled out from beneath the door, illuminating the nameplate that read, Albert Einstein. Inside, a heated debate was underway. Einstein's office was a testament to the chaos of genius. Papers were strewn across the desk and floor, books were piled precariously high, and chalkboards were covered in a labyrinth of equations. Amidst this organized chaos, Einstein and Bohr stood facing each other, locked in a battle of wits and ideas. Quantum mechanics and reality. Einstein, pacing, hands clasped behind his back. Niels, I've said it before, and I'll say it again. I cannot accept that God plays dice with the universe. Quantum mechanics as it stands is incomplete. There must be some underlying reality, some hidden variables that we have yet to discover. Bohr, calmly, though his eyes flash with intensity. Albert, your insistence on determinism is admirable, but it blinds you to the evidence. Quantum mechanics, as we understand it, is a complete theory. The probabilistic nature is not a flaw, but a fundamental aspect of reality. Einstein, stopping to face Bohr. But how can you accept a theory that defies common sense? Particles existing in multiple states at once, collapsing only upon observation. It's absurd. Bohr, smiling slightly. It may seem absurd, but nature does not conform to our expectations. The double-slit experiment, the behavior of electrons, all point to the fact that observation affects reality. The wave function encapsulates all possible states, and it is only through measurement that we see a definite outcome. Quantum entanglement and spooky action at a distance. The debate grew more intense as they delved into the topic of quantum entanglement, a phenomenon that both fascinated and frustrated Einstein. Einstein, raising his voice slightly. And what of quantum entanglement? The idea that two particles can be instantaneously connected across vast distances. Spooky action at a distance, as I call it. It suggests an instantaneous transfer of information, which violates the principle of locality. How do you reconcile this with relativity? Bohr, leaning forward, emphasizing his words. Quantum entanglement does not imply faster-than-light communication. The entangled particles share a common wave function, and their states are correlated. When we measure one particle, we instantaneously know the state of the other, but no information travels between them. It's a manifestation of the non-local nature of quantum mechanics. Einstein, frustrated. It still feels like a violation of causality. There must be some hidden variables, some underlying mechanism that we do not yet understand. Bohr, firmly. The EPR paradox, which you co-authored, attempts to show that quantum mechanics is incomplete. But experiments, including those by John Bell, have consistently supported the predictions of quantum mechanics. The hidden variable theories have not held up to scrutiny. The environment. The office, despite its messiness, was a place of profound intellectual activity. Bookshelves lined the walls, filled with volumes on physics, mathematics, and philosophy. The desk, barely visible beneath the stacks of papers, bore the marks of countless hours of work. A window, slightly open, allowed a cold breeze to circulate, adding to the charged atmosphere within. Hannah, Einstein's assistant, sat quietly in a corner, taking notes and occasionally fetching a book or paper at Einstein's request. She admired both men for their intellect and passion, though she often wondered if their debates would ever lead to a definitive conclusion: the nature of reality. As the evening wore on, the discussion took on a more philosophical tone, delving into the nature of reality itself. Einstein, thoughtfully: "At the heart of this debate is a question about the nature of reality. Is the universe inherently probabilistic, as quantum mechanics suggests, or is there an underlying determinism that we have yet to uncover?" Bohr, gently: "Reality, as we perceive it, is shaped by our observations. Quantum mechanics teaches us that the act of measurement is integral to the existence of a definite state. The universe is not deterministic in the classical sense, but it is governed by probabilities that are as real as any deterministic law." Einstein, sighing: "It is a difficult pill to swallow, Niels. I have spent my life searching for the underlying order of the universe. To accept that at its core, reality is governed by chance feels like an abdication of that quest." Bohr, smiling: "Perhaps it is not an abdication, but an evolution of understanding. We must be willing to let go of old paradigms to embrace new truths. The beauty of science is in its ability to adapt and grow." The role of observation. Einstein walked over to a cluttered chalkboard, erasing a section of equations to illustrate his point. Einstein, drawing a simple diagram: "Consider the role of the observer. In classical mechanics, the observer is irrelevant. The system evolves independently. But in quantum mechanics, the observer seems to play a crucial role. How can we reconcile this with the notion of an objective reality?" Bohr, watching intently: "The observer effect is not an intrusion, but an intrinsic part of the quantum world. The act of observation forces the system to choose a state, collapsing the wave function. This does not diminish the reality of the quantum world. It enriches it by highlighting the interconnectedness of observer and observed." Einstein, frowning: "But this suggests that reality is dependent on our perceptions, which seems dangerously close to solipsism." Bohr, shaking his head: "Not solipsism, but a deeper understanding of reality. The universe exists independently, but our interaction with it reveals its nature. The wave function encompasses all possibilities, and our measurements bring forth specific outcomes. It is a dance between the potential and the actual." A brief respite. Hannah, sensing the need for a break, brought in a tray with tea and biscuits. The two physicists paused, acknowledging her with grateful smiles. The brief respite allowed them to collect their thoughts before diving back into the fray. Hannah, softly: "Would either of you like more tea?" Einstein, smiling: "Thank you, Hannah. Tea would be wonderful." Bohr, nodding: "Yes, please. It's been quite an evening." As they sipped their tea, the tension eased slightly, replaced by a mutual respect for each other's dedication to the pursuit of truth. The future of physics. Refreshed, they resumed their discussion, now turning to the future of physics and the implications of their work. Einstein, thoughtfully. Where do we go from here, Niels? If quantum mechanics is indeed complete, what does this mean for the future of physics? Bohr, leaning back. It means we continue to explore, to refine our understanding. Quantum mechanics has opened up new avenues of research: quantum field theory, particle physics, and cosmology. It challenges us to think in new ways and to seek deeper truths. Einstein, nodding slowly. I suppose you are right. Even if I cannot fully embrace the probabilistic nature of quantum mechanics, I must acknowledge its successes. Perhaps the future will reveal answers that we cannot yet see. Bohr, gently. And perhaps in seeking those answers, we will find common ground. Science is a journey, not a destination. Our debates, our questions, all contribute to the greater understanding. Einstein, smiling. A journey indeed, one that we are privileged to undertake. Quantum Entanglement revisited. As the night deepened, they returned once more to the enigma of quantum entanglement. Einstein, pensively. Quantum entanglement remains a mystery. Despite my reservations, I cannot deny its implications. It suggests a level of interconnectedness that we are only beginning to understand. Bohr, nodding. Entanglement challenges our classical notions of space and time. It suggests that the universe is more deeply connected than we have ever imagined. It is a glimpse into the fabric of reality.